Hello everyone. Let us now discuss how can we solve this problem. So we are going with nothing but this description is so hard to understand. So the question, if I write again, maximum sum without repeating characters, or let it be repeating numbers, without repeating numbers, right? So this is what they give. So what we need to return is maximum subarray sum without any repeating numbers. Now we are given with a nums array, and you might be knowing what is a subarray. So if we take from these two indices and these array in an array, the array in an array from one index to another index is called a subarray. I think you might be knowing what a subarray is. Now, whenever we are asked with a subarray, it is a simple trick or a short that a trick that we need to use this window, or let me name it as two pointers for your convenience. So we need to take this two pointer approach, or you can also name it as this sliding window. Now let us take this example, nums is equal to 4 to 4 4 5 6. Let me write it over here. 4 2 4 5 and then 6. Now if I take this subarray, it is having a sum of 4. And let me initialize maximum sum as minus infinity. And the greatest between these two is 4. So I am just updating maximum sum to 4. Now, can I take this to why I am asking you that can I take this to? Because the subarray which I took till now is having only 4. Now if I take this 2, I can only take when this doesn't have any 2. That's we need to keep in mind. So I am taking 2, so the sum will be 4. Sorry, 2 plus 4, which will be 6. Now from sum and maximum will be updated with the maximum, which is 6. Now if I go to this element in the subarray, or in the array that I am considering, I have 4 and 2. Now the one which I want to consider is also 4, right? So I'll check whether do I have a 4. That's what I did when I went to 2. Do I have a 2? That's what I check. So when I get to this 4, I also check do I have a 4. So how can I remove this 4, right? So I can't remove from the middle that I will remove this 2 and then I will remove this 4, but there might be a chance that this one can be a 2 and other elements can be there after this 4. So we will not be coming from the right, instead will come from the left. So, what if I come from the left and remove this? So, if I am removing, what if I come from the right and remove this? So, if I remove this and this, then I will be starting with 4 again. But the max subarray can be 2, 4, 5, 6. So, what I'll do is I'll just remove from the left. So, the first thing I will remove from the left. Now, I am removing this 4, then after that, if you see again, after removing this from the left, my pointer is pointing here, right? Just don't think about the pointer for now. So I don't have a 4 now in my subarray, right? Now I will check again, do I have a 4? So as I don't have a 4 here, I'll just push this 4 into my subarray, that the subarray which I am considering. Right now, there is might be a confusion that if I add that 4, the sum will be 10, right? So what I'll do, while removing this 4, I will remove 4 from 6, 4 from the sum, which will be 2, right? So if I remove 4 from 6, it will be 2. The sum, current sum of the subarray is 2. and I have removed this 4, right? I have removed this 4, and the subarray is having only 2. Now I have moved this pointer to the next. That means I have only 2. Now I will push this 4 into my subarray. Instead, I'm just considering the sum, right? 2 comma 4. Now I am adding this 4, so I'll update the sum. 2 plus 4 will be 6, and I will check whether max sum has to be updated or not. Now I'll go to the next element, which is 5. So I'll check, do I have a 5 in the subarray which I considered? No. So push that back or add that to the sum. And if the max sum is lesser than the sum, update max sum to the sum. Now I have 6. Do I have a 6 in the subarray that I considered? No. So push that 6 into the subarray, and I am just adding that 6 to the sum 17, and 17 is the max sum, right? So that's what they returned here. But if you see, do I need to carry this subarray? Do I have to carry this subarray? Instead of doing with a vector, let me initialize it with a set of int, right? You might be wondering that what if there are 4 2 4, uh, right? Wait a second, 2 and then 2. Now you might wonder that in this array, then if we are considering 4 first, then the set will contain 4, and then 2, and then it will be 2. So it will be in a sorted manner, right, in a set. So 2 comma 4. Now when you get here, you might wonder that this 2 also will be included into the set, right? But when we are at this index, at this 2, I will check, do I have any 2 in the set? So if I have, I'll just remove all the occurrences, and then I will push one time to uh, the current value, which is 2, into the set. So let us go to the next example, 5 2 1 2 5 2 1 2 5. So here 5 2 1 2 5 2 1 2 5. Now 5 to 1 to 5 to 1 to 5. So here I'll do the same thing again, right? So starting with the first pointer here, I'm starting with the pointers approach, first pointer and the second pointer. Let me name it as L and R. So left pointer and the right pointer both are pointing at 0. Now if you see, the sum for now is 5, and the max sum is negative infinity, right? Now the set contains just 5. Now I'm just taking a large size, right? Now what I'll do is just move this right pointer ahead. Now it is having 2. What I said is check, do I have 2 in the set? And while 2 is having in the set, or if I have, let me take an example like 5 2 1 3 4 and 3, right? Now let me take this quick example. Now if I have L here and R here, I'll be having 5 2. Now I'll just move this pointer ahead, and I'll be having 1 again. Now as I said, I'll check, do I have 1 or not. If it is not there, then I'll move. Now after that, I'll take 3, and 3 is not present in the set, so move, take or consider. Now I'll go to the next pointer. It is saying that 4, so I don't have a 4. Now what I'll do, I'll just take this R pointer ahead and go to 3. Now here comes the conflict that 3 is present in the set already. Now for that, what I'll do, what is the number present at L point, which is 5. So I'll remove 5 from the set. Then why? Because I'm moving my left pointer, the sub array I am considering. Now I have 2. Now 2 have to be removed. Why? Because even after removing 5, this 3 isn't removed. I need to remove this 3, but 3 is again present. So what I'll do, I'll also remove this 2. Now after that, go to the next pointer. So even after removing 2, I still have 3. So go to 1. Now, at this pointer, nums of L is removed. Even then, I have 3. Now, go to the next pointer, which is 3, right? So, remove 3 now. After that, go to 4, and then at this point, I have removed 3. So if I doesn't have nums of R in my sub array, then only set, then only push that back into the subarray. So this is how we solve, but let us look at the example which is given in the question, right? So I will be having just 5 now. 2 is not present, so push it into or insert into the set and add that to the sum. So sum maximum will also be updated for first time 5 and then 7. Now go to the next by R. So it is saying that element 1 is not present, so push that into uh, insert that into the sub array or set. Then I'll be having 1, and if I add that to the sum, it will be 8 and maximum will be updated. Now R will be moved ahead, and it is saying that 2, right? So at this point I need to move the L pointer. At L I have 5, so I need to remove this 5 first. I need to remove this 5, and I'll go to the next pointer by L. So L is incremented to 2. Now even then I have a 2, right? So I need to remove the element at L. So what I'll do, I'll just remove the 2 from the set. But every time I'm removing 5 and then 2, so I need to decrement my sum. uh, 8 minus 5 will be 3, 3 minus 2 will be 1, right? So the L will be moved to here. Now, do I have a 2 in my set? No. So at this point, I will insert the 2 into our set. Now after that, I'll go to the next with R. It is saying that 5. I doesn't have any 5 in my set. But before moving, I need to add this 2 to the sum. 1 plus 2 will be 3. Now after moving to R, I will be having no, I doesn't have a 5 in my set. So push that 5 into the set, and 5 plus 3 will give me 8. Now go to the next pointer R. Next pointer by R, it is saying that 2. What I'll do is just, what is the element at L? 1. So remove that 1 and decrement the sum. I'm just decrementing the sum. If I decrement the sum, 8 minus 1 will be 7. Now increment L pointer, it is saying that 2, right? Now even after removing 1, 2 is also again present. That means it is not removed from the set. So remove the element at L. If I remove that element from set, 2, 2 is removed, then the sum will be 5. So the L will be incremented again. Now after that, I doesn't have any element which is equal to 2 in my set. So if I what I'll do is just insert that 2 and add that to the sum, which gives me 7. Now after that, I will increment my R pointer. It will go to 1. And do I have a 1 in my set? No. 1 comma 2 comma 5. Now I'll go to R, the next pointer 2. Here, before going R to the next pointer, 1 is added to the sum, so 8. Now R is incremented to 2. Now is 2 present in the set? Yes, it is present. So I need to remove the number which is at L. So 5 is removed. 5 is removed. So 8 minus 5 will give me 3, and L will be incremented to the next point here. Now even after removing 2 is again present in the set. So I need to remove 2 from the set. I'll get and also decrement the sum. It will give me 1. Now I'll increment my L pointer. Now at this point, do I have a 2 here? No. So insert that into the set and add that to the sum 3. Now R will be moved to the next pointer 5. Do I have a 5 in my set? No. So add that to the set and add that to the sum, but the maximum is already 8. So this is how you solve this problem. And let me give you the algorithm. First thing, let me initialize L is equal to 0, R is equal to 0, and R stopped when R increments to the n, when R is equal to n. Or let me write it, while r is less than n, then only run a loop. Now, when I have this r, in the set, so I need to initialize set of int. Let me name it as st. Now, while st dot count nums of r, if nums of r is present, then what I need to do, st dot erase nums of L and L plus plus. But before that, sum need to be subtracted. Sum minus is equal to nums of L and L plus plus. Right? Now, sum is added with sum plus is equal to nums of R and R plus plus. But before that, max sum is equal to maximum of max sum comma sum. Now, at the last, we'll be returning maximum. So, this is how you solve this problem, and we need to initialize maximum with negative infinity and sum with 0. So, max sum is equal to negative infinity and sum is equal to 0. So, if you have any doubts, please comment in the comment section, and please do like, share, and subscribe to my channel if you have understood this problem. Thank you.